Yeah, everyone was going crazy right now. Dang. That's fine. If whoever joins, joins. If not, well, next time I learned my mistake. Now I already know what happened.
Did you go live again?
Yeah. Yeah. I already know what happened.
Everyone's going crazy right now.
That's it? Okay. All right. Sorry about that, guys. Yeah. I already know what happened. It's my mistake. So whoever joins, joins. If not, then it is what it is. Okay. So these are the voltages you're going to see when you're out there. Okay. And then you might see 277. Okay. But you three have already worked on these, Andrew, Aiden, and Ivan. You guys have already worked with these right here. Oh, actually, to be exact, there's also 208. You also have worked on those right there. You guys all have worked on them. Not just directly, but guess the thermostat here. How much power does it need? How much voltage? Do you want that thermostat when the customer presses it for them to get shocked with high voltage? So what voltage do you think that thermostat is? 24. The lowest, 24 volts. The 120, that's your furnace power, right? When you connect outlet, when you connect power to your outlet, the furnaces are 120. The condensers that spin, or the package units, in commercial buildings, in commercial, is 208. In residential, because you have high voltage in residential, is 240.
And what that was for?
So this residential, you know the power that goes to your panel?
Yeah.
Right there, it won't be 208, it will be 240 because it's residential. In commercial buildings, it's 208. Yeah, that's the way you know it's commercial or residential. That's how you'll know. All right, cool. I got 10 people. All right, sorry, friends on YouTube. I had the what's it called? Like a little stop when you exceed a certain amount on YouTube. You got to put a passcode. Because at least back in the day, I'm like, you know what? I'm going crazy with YouTube. Camille, my wife, put a time code, and then it worked. And I don't really, because you got to control that. If not, you'll be there all day.
I have the same thing for Instagram.
You got to do it. So you're like, it stops. You're like, okay, I'm done. I'm done. And it went, and that little lock thing showed up, and that's why the YouTube went down. So, okay. But does that kind of answer your question? So yeah, it does make sense, because even in a commercial system, if that chiller or air conditioning system takes 480 volts, it might pull a lot of current. But imagine this. Let's say an air conditioning system, and it takes 240 volts, okay? A 240, it's going to pull less current because there's more power present. If I put a 120 to make up for it, because I have little power, it's going to pull even more. You want to control the current. Current is heat, and it is the current that kills people. Current is what kills people. But just kind of going back to this on the voltage, it is V with this, and I'm going to show you here. On this case, they have VAC. I want to go. You see VAC. We see where the little arrow there, VAC. You see VAC, VAC, VAC. Or it can be V with the squiggly line too, okay? So if I were to check voltage with my meter, if I want to check voltage or potential difference right now, once again, which one am I using? VAC or this one for voltage? Which one?
VAC.
Okay, so look, VAC. What am I getting?
120.
120. You got to get 120. And you'll see here in the United States, it's 120, 60 hertz. Electricity travels back and forth 60 times a second. You'll see that in appliances. If you go to other countries, I was in Paraguay last year. I think I mentioned it to you guys. Over there is 50 hertz. I don't know why, but it's 50 hertz. That's what they use. For us, though, it's 60. So sometimes when you buy it, when you take, like my wife's friend took to curl your hair, and it was only 60 hertz. So when she connected it, and over there, the outlet power is 240 volts. It's high voltage. Mm-hmm. It's completely different. But a lot of the components that you buy on Amazon and you buy it here, they're already made international, so you don't have to worry about any of that.
Well, I mean, in Europe, most Europe, but they're still doing 110, I think, over there.
Yeah, certain parts they're doing 110.
Like Armenia, I was in Romania.
Okay,
Yeah,
in Bucharest or where?
The
capital?
The whole Romania.
Oh, nice. Yeah.
That line is all mountains.
It's 110. Okay, so then other places, yeah, they'll do like South America, the countries I went
You
to.
gotta have the, safe converter to just.
You need that converter,
You need
yeah.
a converter, but you need to have a safe converter. You can't just put any converter.
You gotta confirm that, because the worst thing you can do, if it's 240, you put your 110 up load,
Boom.
kaboom. If it's 110 but you put a 240, it might just not turn on. But when it's the opposite, boom. So just be mindful of that. So okay, you guys saw how easy it was to check. Not too bad, and you guys are gonna be doing that today. I'm gonna go ahead and put it here, right? Okay, I'm just gonna put it in here, and then you guys are gonna have to kind of push in. I know these get kind of weird, and you have to kind of move it. 120, okay? So right now, there is power in there, and I gotta be safe and careful, okay? So that's okay though. So we'll get to that. When we get to that, we're gonna take it step by step. This right here, this is what makes things happen. Right here, current. So imagine in a wire, you got little balls like this, okay? This is what travels back and forth 60 times a second, okay? So current is actually what kills people too. I didn't know if you guys knew this, but your heart actually has hertz too. It's got current. Your body has this too, and when current hits you, it can mess up a lot of your internal organs. But I'm gonna show you guys with this example how to measure current. So right now, do you guys see anything on right now? Do you guys see anything on right now on this panel right now? No. Okay, that's simple. So what I'm gonna do, I'm gonna go ahead and power up this light bulb. Now I know some of the guys on YouTube might be like, wait, you're gonna power up 24 volts to 120? Because that's what I'm gonna do. This light bulb that I bought is 24 volt light bulb, but typically it is a 120 volt light bulb, but I changed it. So the way I have it wired, okay, we got voltage. We'll talk about transformers, right? But this is receiving 120 volts, right? And let's confirm, right? Actually, I should probably not use my rings. So let's go ahead and put it here. There we go. 120, right? I got power. And when you guys use these leads, make sure it's pushed in all the way. And you got the little rings right here. This is to keep your finger from sliding. So if it slides, you're gonna get shocked. So here we go. We got a 120 here going to my transformer. A transformer, all it does is steps down the voltage from 120, 24. How do we know we have 24 volts? Let's go ahead and put it here. Okay, actually I'll put it right here and I'll show you guys right now. 24 volts, okay? So you see 27. When you see 27, 26, guys, it's 24, okay? What I would be worried though, if it's 22 or 23 volts, then I'm like, why is it low? If it's 27, that's actually good. Remember, HVAC is not black and white. There's gray area, so 27, it's good, okay? So I have power. This transformer is doing its job. Let's go ahead now and turn on this light, okay? So all I'm gonna do is just connect power here, okay? Because remember, it takes two. You guys know it takes two to tango, right? It takes two to complete a circuit. It takes two to tango. So, okay. Now, because it's on, do you think there's current flowing through that? Yeah. There is, 60 times a second, boom, 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 and it's making something happen. Great. Now I can check amp draw. So I'm gonna go ahead and put select. And have in mind this meter, sometimes when you're on the setting, you actually have to push select until you get to the one you want. It won't do it automatically. So this one, amps, I'm pulling 0.3 current. And they say that 0.5 can kill someone under the right circumstances. And I could be wrong on that number. I forgot the specific number. But regardless, even if it's 0.3, I'm going to be careful. Okay? But you see, it's pulling current. Let me go ahead and disconnect it. If I disconnect it, you think it's going to be pulling current? Exactly. That's what I want you guys to know. You can only check amp draw if it's on. It has to be on. And that current is important because a lot of these compressors, they'll tell you how much it should pull. And if it's pulling more current or less, there's something going on. It's part of a symptom, part of you of troubleshooting and seeing what's going on with that component. Okay? So current though, remember, to have current though, and isn't it true that we need a path? Let's go ahead and, what is it? Did it disconnected? Are you going to troubleshoot on me right now? Man. Oh, I think what's going on. Sorry. So, I want to turn it on. I want you to not turn on. Okay, so right now, you see how it's not turned on? Going back to current, okay? Remember, you need current, okay? You need a path. You need to be able to send this all the way over here. So if it's not turning on, what do you think are some of the things that I would do first? What do you think I would do? What do you think is bad? Yeah, you could check the switch. So the switch is good, but let's say, sorry, it was this one. That was weird. So let's say, right, it should be on, right? If I put this wire here, right? This one should be on. Where's the bad one? Oh, it's right here. All right, and I already said bad too, so you guys already know what's gonna happen. Oh, you see, I think there's something loose in that little switch. Yeah. You see, it's turning on and off? Man, of course, you're doing it right now when I'm trying to prove a point. That's all right, that's all right. But you saw how I turned off and on? Yeah, I think something's loose in there.
Check if it's not the jumper, because I'm thinking that
You think it's probably the jumper?
could possibly be.
Oh, is it this one here? Look at that. And it's
probably making false contact.
yeah, and it was touching the copper too. That was weird. Okay, going back to the point. Goodness. All right. So the bad one. Can you hand me one of those? What I want to show you guys is that just because everything's wired, thank you. Just because everything's wired, it doesn't mean it's gonna work. Okay. So let me go ahead and disconnect this one. Let's see this one here. Okay. This one works, huh?
Those didn't have continuity. I'm just trying to check them right.
No, it's okay. It's okay. You're good. You're good. He's gonna check it. I'm trying to prove a point here, but what I want you guys to start thinking is when you go to a job and you see all the wires, that wire, what's inside of that wire again? What did I show you guys? Copper. What if that wire's ripped? Can current flow?
No.
So when you go to a job, you're like, there's a possibility the wire can be ripped, it can be broken, something could happen. So that's your job. While he checks those, I want you guys to start writing this one down right here too. This right here is continuity. Ensures there is a path. Okay? Thank you. Thank you. All right. Okay, right there. That right there, that light bulb, it should turn on. How can I confirm? Look at this right here. Volts VAC, okay? I'm gonna check the source of my 24 volts, which is the transformer. Let me go ahead and check here. Sure I can do it. What am I getting? 27. Okay. So obviously I should be getting what here? 27. So now I'm gonna check it. 0. That's where continuity comes into play. Like now, what I'm gonna do, wait, if my wire's bad, then current can never go through. So you're gonna look for that little Wi-Fi signal. That's what I call it, continuity, right? You guys see the little Wi-Fi signal right there, right above my finger? It looks like a little dot
I see it.
right there. Look, and the way you wanna test this, because your meter can fool you too. You see when I test both of them, you can hear it. Now let's test it, there's a path. How can the light ever get power? There's no path to this. So, bad wire. Now, a lot of the times, your wires are not gonna be like that where it's not working from here to here because something happened inside, but they'll start like vibrating, or sometimes they could get cut or pinched. That's how you check it if there's a path. But we're doing that because we wanna make sure that current makes it to that light bulb. So, going back to this example again, okay? Good. Now, okay, now, remember there's three things, right? What are they again? Before, without looking, what do you think? What are the three things to a circuit? Voltage, current, and my light bulb, my load. All right, good, good, good. So you guys know the example I like to use, right? The bloods and the cribs, right? The bloods and the cribs, right? You see that? It's funny. You know what I just saw, Alexis? I literally saw this part here disconnect in front of my eyes. Gosh, man, all these wires, man. These are the other ones. All right.
Keep those because those are gonna be.
Yeah. Okay. You see that? See that? The Bloods and the Cribs, gang members. They don't like each other. They're gonna fight. But if they go to Homeboys Industries, to a gang rehabilitation center, they can work together. Right? They can work together. But when you have the current touching each other before it reaches the load, that's called a dead short to each other. You do not want that. You see, if I leave that there, that's gonna burn the transformer. Transformer's bad.
What did you say it was called?
A dead short. A dead short. It's a short. They call it some. Sure, it's a short. But there's two types of shorts that are common though. Dead short, which is dead short to each other before the load, and shorted to ground. When you see the little copper and now it's touching the actual metal, that's short to ground, which we'll go over sometime this week. But you can have two types of shorts. And I'm sure there's other ones that electricians maybe call and refer to, but right now, dead short, right? Bloods in the Cribs, right? They're gonna touch each other, they don't like each other, but if they can work together by going to Homeboys Industries or that gang rehab center, hey, they can make stuff happen because now they can work together, but they cannot touch each other. They must go meet here in the load. The load has to be in between.
So it means current touches each other before getting.
That's it. That's dead short. When current touches each other, that's a dead short. And then when it's a short to ground, is when that current, maybe this wire is stripped and it's touching the metal. You only want that current to go to the load. Remember, the unit vibrates, right? Packaging is not installed right. It can get stripped and then touch the metal. And then, the current's not going to the load anymore. Now, of course, this is 24 volts because look, even though you see that, it's crazy, but I'm touching it and I'm okay. Now, I'm not encouraging you guys to do this, but what I'm saying is that there's a little bit of voltage and I don't think it can overcome the resistance that my body brings. Just be mindful though, okay? Especially when dealing with 120. I've gone to very humid attics where I was kind of close to it and it shocked me just a bit because the way, and just going back to this, the reason why copper is a good conductivity, right? I think I showed you guys copper's a good conductivity. Copper's a good conductivity because it has to do with a little bit with chemistry. It's called valence electrons. Copper's just a good conductivity. Silver is. Think about those things that are not good conductors. What do you think? Rubber. A 2x4 wood, right? If I'm getting shocked, right, and I can't move, And Andrew comes and touches me, he's gonna get shocked. So you gotta get a 2x4 and knock his hands out of that. But copper is a good conductor though. It's a very good conductor. Silver, but like rubber and wood, those are not good conductors though, right? So that's why they tell you, right? When you go do electrical, use a fiberglass ladder. You don't wanna use aluminum. You'll get shocked with aluminum. I'm sure you guys have seen those YouTube, TikTok, where guys, boom, because of aluminum conducts. So going back with the water example, water is not a good conductor, but it does have some valence electrons, a little bit. So if you were to throw water in there, it would, because it could create a path. So the other example, I'm trying to remember the other one, there was, yes. So this was, just to kind of give you guys an idea with this, and this is where we have to do with safety. And the other instructor I used to work with, he said that a guy was working on a unit, sat down on a bucket, very humid though. And I don't think that bucket was plastic too. He was working on it. Everything was, he was just sitting down. He opened up the panel, and a wire that was supposed to be screwed, for some reason came out, got him on the eye. Came out through his butthole. And to this day, he can't see from this eye. He can't go to the restroom correctly. Wow. Yeah. So I don't know. I think the current must have flown through. I don't know what kind of bucket he was using, but you have to be mindful. Electricity likes to go to ground. Thunder, where do you think goes to? To ground. It likes that. If you give it a path though, it will go through you. It's gonna go through you. So just be mindful of electricity, right? Right now though, even though it's 24 volts, it's just very little current, there's very little voltage. I'm okay. I'm not telling you guys to do that though. Always use a meter and check, right, if it's got power or not. Down there, remind me, I'm gonna tell you guys another story that happened, right? But I'm not saying this to traumatize you. Guys, there's more to just electricity. Please be careful. Please be careful. This would shock me if it wasn't insulated. You see, I'm touching it, it's 120, I'm okay. But if there was a little nick here, it would hurt me, right? If I were to touch both, hurt me even more. 480 volts, that's even higher voltage. You touch that, it'll push you 10, 15 feet back. If you're on the roof of a third-story building, you'll fall over. You gotta be careful. So please use a meter, use gloves, use glasses. Another thing too, when you're gonna check voltage, make sure that it's VAC. Because if you have it in resistance, which that's the last thing we'll go over before we go down there. Like for example, this load, I need to put it on resistance. But if I'm checking power with it, you end up blowing the little fuse that it has in there. Some of these meters, it happens with that. But now that let's see, no more power, what is it on? Okay, like this one here. Remember, we just checked current, we checked voltage, right? And then this light bulb here, we're gonna go ahead and put it on my horseshoe. You see right there? Horseshoe. It looks like a horseshoe, but it's part of I think it's part of the Greek alphabet or something. Omega, yeah. I said horseshoe last time on one of the videos. Man, this guy let me have it. I'm like, Greek alphabet, what the heck? Like, I mean, you're right, but like, man, chill. So
there's a watch brand they call Omega. So.
Yeah. Yeah, it is. Yeah. It is. So look, right now I have it, it's open line. I'm gonna go ahead and connect it. Just check. You see, I'm getting a number. There's resistance. This is the key. You want resistance. Resistance slows down current. Remember what happened to the Bloods and the Crips? There's no resistance. Your load has resistance. It slows down current. So it's good. Guess what? If you go to a job and you check whatever load and you check it and it says OL, then I would check maybe that load is bad. It should not be OL or open line. It should not be open line. You got to have a load. So as we go over contactors today, we are going to make more sense out of that, okay? But like I said, there's three things that we've talked about. Current, this is important. This is, if we had a chance to get rid of this and just had current, that would be great. because current is what makes things happen. Things turn on. But the reason why we need voltage. Let's see if you guys can get my drawing here. The morning class got it. If you guys don't get it, you guys will make me sad. So, let me see. The guy in the morning already got it right now. Seesaw. Thank you, Andrew. Made my day. I'm the worst in drawing though. But imagine that seesaw going like this, 60 times a second, and it had little balls. Wouldn't the balls move? This way, this way. That's what a potential difference. That's what a voltage does. It allows you to do this. And someone thought about this. I don't know if they had a lot of weekends available, but when you have current going back and forth on a wire 60 times a second, it creates a magnetic field that you cannot see with your eyes, a magnetic field. And that magnetic field turns stuff on. Now this one is a pure resistive circuit. What you guys are going to be working on are inductive circuits. And like I said, we're just going to keep it simple when it comes to inductive circuits because it's not that hard. So, but three things: voltage, current, and load. You need to check resistance. Okay? How are you guys doing? Okay? Yeah? Okay. I think I did the thermostat earlier. So, what time is it, Alexis?
It is 6:49.
Okay, I'm gonna do 11 more minutes then, and then last hour I'll have you guys just work. Cause, yeah, I mean, if I go crazy with, even though it's not crazy, but if I go too much with electrical, you're gonna be like, what the heck? Okay, now let's introduce the thermostat. Okay, the thermostat, T-stat. Okay, RHRC, common, YGW. This is yellow. Cooling, this is green fan, and this is white heating. This is common, typically for residential is a blue wire. This is red, and this is my power. This is thermostat, okay? These right here are my actions. Okay, so go ahead and write that down, okay? And then we'll go over contactors when we start working on the panels. So go ahead and write that down. RH, RC, that's my red wire, which is power. My C, that's common. It's a blue one. And then Y, yellow, G, green, W, white, cooling fan, heating, okay? This is a very simple conventional system, okay? And I'm gonna show you guys how to use a thermostat to turn on this light bulb, okay? So we'll talk about that right now. And after that, then we can start doing the hands-on. I know it's hard because you guys work all day and it's hard to take in more knowledge at the end of the day, so. Okay, so my thermostat. And this part here, where do I put that? So you see right here, I got, and this one here, you know, the other little, oh, it's right here. I don't want to be confusing, but I'm going to go ahead and just switch. Let me see if I could do it here. All right, just bear with me right here. Okay. Okay, so we need to power up this thermostat, okay? So we just said my thermostat, my RH, my RC, which is right here, RH, RC, my red wire. Do we have a red wire going to that thermostat right now on the RH, RC?
Yeah.
We do. Good. My red wire is right here. So it doesn't matter which one you use, right? Is it on? Oh, now it's on. Yeah. So I should not have checked it like that. Use a meter, guys. Use a meter. Don't do that. So it doesn't matter which one you decide to use, but this one's gonna be power. Okay, I'm done. Remember, it takes two to tango, right? So we need which one do we need to complete the circuit? Common. Common. So common, we just said is blue. Put it here. And make sure that it actually is on C. That blue wire is on C, because if it's somewhere else, then it's not gonna work. So now, go ahead and turn it on. Just power. Good. Okay. Now we're gonna use this thermostat to turn on that light bulb. Okay, so this is what I like to say. With any circuit, anything that you're dealing with, any load, my common goes home run, just like the Dodgers, okay? Home run. So common, like I said, common, go ahead and put it here. Man, I hate these sometimes. Okay, common goes straight to home run, meaning that, you see, it's going from common straight to that wire. There's nothing interrupting it, right? It's going straight to that wire. Now, let's just use heating, okay? What do you think I have to do right here, from here to here? Let's say I want heating. When there's a call for heating because it's too cold, I want to turn on that light bulb or that furnace. What wire do you think I need to do? What 2 wires do I need to connect if I want heating? So I'm trying to turn on that light bulb, and I got 1 wire here sticking. That wire's gonna need something, right? And I want heating.
White.
White. There we go. White. So look what's gonna happen. Right now it's not on because I don't have a call for heating. Let's get a call for heating. Give it a second. So my thermostat, what it does with the red wire, it has the 24 volts. It's holding on to it. You have a call for heating? Here you go, white wire. And it gives the 24 volts to the white right here. And it powers up the light bulb. So the thermostat is just a switch, guys. It's just a switch, right? Like you go to your room, on, off. It's just a switch. So, but you don't have to be there to do it all the time, because are you going to really be like Mrs. Applebottom? You want heating? Okay, boom, on. No more? Let the thermostat do that for you. But you got to have it on heating, and you got to be above the ambient. For the fan, same thing. For my fan, turn it off. Okay. This is independent fan, meaning that it's not going to be hot or cold. It's just going to be air coming out. On. There you go. Now it gave it on the G, on the green. But if I have it on the somewhere else, nothing's going to happen, because we just said green is for fan. If I want cooling, where does this wire have to go to?
Yellow.
All right, yellow. It's right there, right? It's not too hard. Yeah.
I wish it was right there all the time.
So now that it's cooling, the red wire, internally the thermostat is like, hey, I have a call for cooling. Here you go. Boom. And it gives it to yellow. So basically it closed the bridge between these two like that. So this is where troubleshooting comes into play, because you're like, what if, just for the heck of it, what if when you check, you're like, let me check. And you're going to voltage and you check. So think about this, okay? Just think about it for a second before I actually say this. What do you think my voltage would be between common and my yellow wire? Right now, there's a call for cooling, right? Huh?
24?
Good job, Todd. Dang. You're like Andrew in the morning, yeah. Andrew got it right. So look guys, common and yellow, I'm getting 27 volts, right? When I don't have a call for nothing, it's 0, because yellow now lost 24 volts because I don't have a call for cooling. It's not getting the 24 volts from my red wire, my power. So that's troubleshooting, because it could be wired wrong, it could be a bad thermostat head, or the wires could be bad. This is where you come in troubleshooting. So that's what we're going to do today. I'm not going to go over contactors. We can go over that tomorrow or Wednesday. But we can actually talk about it today. So today we're all going to try to get a panel. I'm going to have you guys, if you guys start getting crazy, which is good, I want you guys to learn this in 2-3 weeks, all the electrical. So the last week you're bored, which is good. I'd rather you guys do that than the last week you're still trying to understand electrical. But if you guys get ahead, today me and Alexis will give you service calls. And you're going to have to show it with your meter, not with wires, but with your meter that, okay, that's the issue. If not, we won't let you fix your issue with this. You only get it when you prove to us with the meter. Because that's good for you guys. Electrical, 80% of the jobs or electrical, the problems rather. So you guys want to pay attention in this module. But today, that's all we're doing. Just we'll mix up a circuit, thermostat, and then we can introduce the contactor right now. Yeah.
We'll let them
So-
kind of power on the thermostat, check those voltages, and then we'll go from there.
Yeah, so we can maybe clear up. We have enough meters for everyone. And then, we can get a panels. And you guys, one of you guys can get this one too.
Yeah, so we have enough boards, guys, so just grab a board and then just find a good...
All right, guys. So, I apologize. I know I cut out. I think I know what happened. I have a setting where it, after so long, it cuts off and I have to put a passcode. And I removed that setting. That's not gonna happen next time, but I'm gonna try to do this here and there when I can, maybe next week. So stay tuned. Thank you for joining, and I'll catch you guys later.
We are going to be getting more voltage, but I do want you guys getting in the habit of protection. Yeah.